Welcome to chemistry classes. In this video, we are going to discuss about properties of D block elements. Properties of D block elements. And this is the second part of D and F block elements. Clear? In this video, we are going to discuss about magnetic properties, formation of colored complex, catalytic properties. Also, we will discuss lanthanides. Okay, we will discuss here F block elements. Okay, so here these are the things we are going to discuss in this video. Here first we have to discuss here magnetic properties of D block elements. See here, there are two different type of magnetic properties. Paramagnetic substance and diamagnetic substance. These are the two different type of magnetic properties, paramagnetic properties and diamagnetic properties. Paramagnetic properties means substance it will attract towards applied field. Okay, substance it will attract towards external magnetic field. Such type of magnetic properties here paramagnetic substance. Similarly, diamagnetic substance means substance it will repel with the external magnetic field. Substance it will repel with applied magnetic field. Such type of substances are called diamagnetic substance. So these are the two different type of magnetic properties, diamagnetic and paramagnetic substance. Most of the D block elements are paramagnetic in behavior. In substance. Okay, substance it will attract very strongly towards external magnetic field. Such type of magnetic properties are called ferromagnetic substance. Ferromagnetic substance means substance it will attract very strongly. Okay, such type of magnetic properties are called ferromagnetic substance. Okay, and here one more thing we have to understand, magnetic properties of D block elements depends on the number of unpaired electron. Magnetic properties of D block elements depends on the unpaired electrons, number of unpaired electron. So here in this video we discuss here there are two different type of magnetic properties, diamagnetic and paramagnetic. Most of the D block elements are paramagnetic. Paramagnetic substance means substance it will attract towards external magnetic field. Diamagnetic substance means substance it will repel with applied field or external magnetic field. Substance it will attract very strongly towards applied field. Such type of magnetic substance, such type of magnetic property called ferromagnetic property or ferromagnetic behavior. Okay, and here the magnetic properties of D block elements are depends on the number of unpaired electrons. Clear? Okay, so we discuss here magnetic properties of D block elements. Magnetic properties. To find magnetic property of D block elements, we can use this equation, mu equal to root of n into n plus 2. Mu equal to root of n into n plus 2. Okay, this is the equation to calculate magnetic moment. Okay, magnetic strength we can calculate using this equation. Here n represent number of unpaired electron. Number of unpaired electron, and mu represent magnetic moment, and unit of magnetic moment Bohr magneton, and this is the symbol. Bohr magneton is the unit. Clear? So here magnetic properties of D block elements depends on the number of unpaired electron, and magnetic strength increases with the increasing number of unpaired electron. Okay, substance with a higher number of unpaired electrons showing higher magnetic strength. So magnetic strength increases with the increasing number of unpaired electrons. Clear? Okay, look here. Here you can use this calculation. See here, the substance which contain only one unpaired electron. So you can find magnetic moment n into n plus 2. So one unpaired electron. So n equal to 1. Okay. Substance which contain only one unpaired electron. So n equal to 1. So you can use this equation 1 into 1 plus 2. 1 into 1 plus 2. So when you solve this, you will get answer around 1.73. So substance which contain only one unpaired electron, its magnetic moment will be 1.73 Bohr magneton. 1.73 Bohr magneton. Similarly, you can do calculation. Substance which contain two unpaired electron, its magnetic moment around 2.8. 3 unpaired electron 3.87. 4 unpaired electron 4.9. So you can see here one common behavior here. Substance which contain one unpaired electron 1.7, 2 unpaired electron 2.8, so 3.8, 4.9. So from multiple choice question you can find its answer very easily. Clear? Now here we have to understand magnetic moment. So sometime you can see question like this: find the magnetic moment of scandium 3 plus. Scandium 3 plus. So you have to write, scandium 21. Scandium atomic number 21. Here 3 plus means 3 electrons are less. Okay, 3 electrons are less. So you have to do the subshell electronic configuration. Okay, in subshell electronic configuration you can see 3d0. 3d0 means there is no unpaired electron. We consider unpaired electron in d orbital because we are talking about d block elements. D block elements, we need unpaired electron. N mean unpaired electron, number of unpaired electron in d orbital. So here in scandium 3 plus, number of unpaired electron in d orbital 0 unpaired electron. So here n is equal to 0, so magnetic moment will be 0. Okay, so here calculated magnetic moment. Calculated magnetic moment mean we know number of unpaired electron 0. Okay, and using calculation we can see here calculated magnetic moment 0. Similarly, observed magnetic moment. Observed magnetic moment mean with help of instrument we can observe the magnetic moment. This is also 0. So observed magnetic moment and calculated magnetic moment 0, because here number of unpaired electron 0. Clear? Also here vanadium 2 plus, you can write subshell electronic configuration of vanadium 2 plus and you can find 3d3. Subshell electronic configuration end with 3d3. So how many unpaired electron? 3 unpaired electron. So you can do the calculation and you can see here 3 unpaired electron, so its magnetic moment will be around 3.87 Bohr magneton. Okay, so you can find magnetic moment of this type of ion. You have to do the subshell electronic configuration. You have to find number of unpaired electron in d orbital, then use this equation. Clear? So also you can see here one table. This table shows different ions and their magnetic moment, observed magnetic moment and calculated magnetic moment. Clear? Okay, next one we have to discuss here formation of colored ions. D block elements forms different type of colored compound. Okay, so we have to discuss about this. So see here, in normal case all d electrons are in lower energy level. In normal case all d electrons are in lower energy level. when they absorb energy, when this d electrons absorb energy, it will excite to higher energy level. During this excitation, it will absorb radiation from different frequency. Okay, and this frequency, this absorbed frequency, it will lies in visible region and it helps to make colors. So here we are talking about formation of colored ions. D block elements forms different type of colored compounds. Okay, in normal case, all D, we know 5d orbitals, dxy, dyz, dxz, dx square minus y square, dz square. These are 5d orbitals. All 5d orbitals in same energy level. When they absorb energy, it will excite to higher energy level. During excitation, it will absorb frequency of radiation. And this frequency of radiation, it will stay in between visible region. It will lies in visible region. And it helps to make different colors in D block elements. Okay. And here we have to discuss here the formation of colors. So here we discuss here D block elements, D block metals, it make colored compounds, and these colors depends on the frequency of light absorbed, frequency of light or frequency of radiation absorbed. Also it depends on the substance which attached to metal ion. Substance, example OH minus, NH3, Cn minus. Okay, these are different type of substance. It will attach on D block metals. Okay, depends on this substance, D block metals form different type of compounds, different type of colors. Okay, so here we are talking about formation of colored ions. How D block metals forms colored ions. In normal case, all D orbitals are in same energy level. When they absorb energy, it will excite to higher energy level. During excitation, it will absorb frequency of radiation, frequency of light or frequency of radiation. This frequency of light lies between visible region, and it helps to make different colors in D block metals or D metal compounds. Okay, and it make different colors. These different colors depends on the amount of radiation absorbed. Okay, also it depends on the substance which attached to D block metals. Okay, substance such as OH minus, NH3, Cl minus, these are the different type of substance it will attach on D block metals. Okay, if there is depends on this, they produce different type of colors. Clear? Okay, next one we have to discuss here catalytic properties of D block elements. D block metals or their compounds used as catalyst. Okay, here this D block metals, they make various oxidation state. They have ability to make various oxidation state, different oxidation state. Okay, also this D block metals, it absorb reactants on the surface of these metals. Okay, because of this property, D block metals or their compounds used as catalyst. D block metals such as vanadium, D block metals such as iron, powdered iron used as a catalyst in the production of ammonia. Production of ammonia, Haber process, iron used as catalyst, powdered iron used as catalyst. Similarly, hydrogenation of alkene, addition of hydrogen to alkene. Okay, during this chemical reaction, nickel used as catalyst, vanadium oxide, V2O5, vanadium oxide used as catalyst in contact process. Contact process means production of sulfuric acid. In production of sulfuric acid, V2O5 used as catalyst. Okay, so here D block metals or their compound used as catalyst because these metals they have ability to make various oxidation state. Also these metals absorb, it will absorb, not absorb, it will absorb, chemically absorb reactants on the surface of metals. Okay, so here we discussed V2O5 used as catalyst in contact process, powdered iron used as catalyst in Haber process, nickel used as catalyst in hydrogenation of alkene. Okay, so look here, this is one chemical reaction. This is one chemical reaction here Fe3 plus used as catalyst. See here 2I minus plus S2O8 2 minus giving I2 plus 2SO4. This is one chemical reaction. Here Fe3 plus is catalyst. Okay. Actually this chemical reaction takes place in two steps. In first step Fe3 plus reacted with I minus will change to I2. Okay, also here Fe3 plus is reduced to Fe2 plus. Fe3 plus changed to Fe2 plus. Next step, this Fe2 plus react with the S2O8 2 minus. Fe2 plus reacted with the S2O8 2 minus, then S2O8 2 minus will change to 2SO4 2 minus. S2O8 2 minus, it will change to 2SO4 2 minus, and here Fe2 plus changed to Fe3 plus. So in the beginning it was Fe3 plus, finally it is Fe3 plus. So here Fe3 plus act as catalyst. Okay, so here we discuss catalytic property. Here D block metals or their compound used as catalyst, and these are the example: contact process, Haber process, hydrogenation of alkene. Okay, also why these D block metals or their compound used as catalyst? Because these metals have ability to make various oxidation state. Also they chemically absorb reactants on their surface. Clear? Okay, next one we have to discuss here formation of interstitial compounds. Interstitial compounds. Interstitial compounds means small metals such as hydrogen, carbon, nitrogen. This type of elements, small type of elements are trapped in the lattices of metals. Small elements such as hydrogen, carbon, nitrogen are trapped in the lattices, lattices of the metals. After that it will change to interstitial compounds. Okay, and this interstitial compounds, example here: titanium carbide, manganese carbide, iron hydride, titanium hydride, vanadium hydride. These are example for interstitial compound. See here titanium hydride, here number of hydrogen 1.7, 1 titanium and hydrogen 1.7. Vanadium hydride, 1 vanadium 0.56, its ratio coming like that. Okay, and here this type of small elements trapped in the lattices of metals, it will change to interstitial compound. And this interstitial compound, see here one metal and non-metal, but they are not pure ionic or covalent. Okay. Also some characteristics compared to pure metals, this interstitial compound shows higher melting and boiling point. They shows higher melting and boiling point, and they are very hot and they are very good conductor compared to pure metals. Most of the pure metals also pure conductor. Also this interstitial compounds also shows metallic conductivity. They are very hot. Okay, compared to pure metals, interstitial compounds shows very high melting and boiling point. Also here interstitial compounds are chemically inert. So interstitial compounds are formed small elements such as carbon, hydrogen, nitrogen are trapped in the lattices of the metal. Clear? Okay, next one we have to discuss here alloy formation. Alloys are homogeneous mixture of solid solution. Here we have to discuss here next one alloy. Alloy mean it is homogeneous mixture of solid solution. Okay, and here compared to pure metal, alloys shows some better qualities. Alloys are much harder and it shows very high melting and boiling point compared to pure metals. Okay, also alloys resist corrosion. But compared to pure metal, alloys are poor conductor of electricity. Okay, alloys are poor conductor compared to pure metal. Okay, also alloy shows high melting and boiling point. They resist corrosion. Also here alloys are much harder. Okay, but when you compare with the pure metal, alloys are less malleable and ductile. So compared to pure metal, alloys are poor conductor, alloys are less malleable and ductile, but alloys resist corrosion. Alloys are much harder. Okay, also it shows very high melting and boiling point compared to pure metals. That's why we will convert pure metals to alloy. Here some example for alloy. Ferrous alloy mean alloys of iron. Okay, so alloys of iron we have to remember two important alloys of iron: mild steel and stainless steel. Mild steel which contain iron, nickel, chromium, manganese. Mild steel which contain iron, nickel, chromium, manganese, etc. That is stainless steel. Here we have two steel, stainless steel and mild steel. The first one stainless steel which contain iron, nickel, chromium, manganese. Not mild steel, stainless steel which contain iron, nickel, chromium, manganese. Okay, mild steel which contain iron and carbon. Mild steel, iron and carbon. Stainless steel it contain iron, nickel, chromium, manganese, etc. Okay, another two example for alloy: brass and bronze. Brass which contain copper and zinc. Bronze which contain copper and tin. Okay, both contain copper. Brass which contain copper and zinc. Bronze which contain copper and tin. These are the things we have to discuss in this video. Okay, and rest of the things, F block elements, we will make another video. So here we discussed different properties of D block elements: magnetic property, formation of color, catalytic property, and also we discussed here alloy formation. This type of things we discussed here. Okay, so you can watch next video for F block elements. So thank you for watching this channel.